Greetings, mathematicians. We have example 4, the AND special cases. Solve and graph the following AND statements. So let's take a look at this first inequality that we have up here. So we have 5 is less than or equal to x minus 4 is less than negative 13. Okay, so we're going to do the same thing that we did with those previous AND statements. We need to go ahead and isolate the middle. So we're going to go ahead and add 4 to the left, the center, and the right. Those 4's cancel out. 5 plus 4 gets me 9, less than or equal to x, and then less than negative 13 plus 4 is negative 9. Okay. At first glance, this looks good, right? I have my variable isolated, but let's see if we can make sense of what's going on here. We want to make sure that our answer is written from least to greatest. Negative 9 is smaller than 9, so I'm going to go ahead and rewrite it. So we have negative 9, and then we're going to flip everything. So we have negative 9 is greater than x is greater than or equal to 9. Okay, so let's see if we can think this through. This is technically an AND statement, so I can go ahead and break this apart. So we have x is less than negative 9 and x is greater than or equal to 9. Okay. I'm thinking to myself, is there any number that satisfies that inequality? Are there any numbers that is both less than negative 9 and at the same time greater than 9? There are no numbers like that, right? So this is no solution. There's no number that is both less than negative 9 and greater than or equal to 9, right? So if I go ahead and look at that graph, I can put negative 9 right here. I can put positive 9 up here, right? There's nothing to graph, right? Because the graph is the solution set that satisfies the inequality. So we're just going to leave that graph blank. Okay? Let's go ahead and take a look at that next inequality. So this next part here. We have negative 3 is less than negative 1 minus 2x, less than or equal to negative 5. So again, we need to isolate the variable. So I'm going to go ahead and add 1. Those cancel. Negative 3 plus 1 is negative 2. Less than negative 2x. Less than or equal to negative 5 plus 1 is negative 4. Okay. So let's go ahead and divide by negative 2. Left, center, and right. Okay. So these negative 2's, they divide, they cancel out. So we have negative 2 divided by negative 2 is positive 1. Okay. I'm dividing by a negative 2, by a negative number. So I have to take these inequalities and I have to flip them, right? So this less than really becomes a greater than. I have x, and then I have greater than or equal to, and I have a positive 2. Okay? At first glance, this looks good, right? Because I have my numbers are from least to greatest. But check out these inequalities, right? These are greater than and greater than. Normally for AND statements, it's always going to go from least to greatest, so it's going to be less than, right? So again, we can break this down similar to what we did up here. So this really is equivalent to x is less than 1 and x is greater than or equal to 2. Okay? I'm thinking to myself, is there any numbers where that's the case, where it's both less than 1 and greater than 2? The answer to that is no. So this is also no solution. And same thing, the graph, we can't graph anything, so we're just going to leave that graph blank. So I'm going to put 1 here, and I'm going to put 2 here. And again, there's nothing to graph, so we're just going to leave that blank.